Hello everybody, my name is Jim Elliott and I am the Vice President of Memory Marketing at Samsung Semiconductor Incorporated. Wanted to speak to you today about SSD and DDR3, which is memory's best power play. This presentation will take about 15 minutes. So if you look at the semiconductor's role in green technology enabling and specifically to memory on this first chart, you can see down here at the bottom SSD and DDR3 are really the building blocks for this larger ecosystem. And these will have a profound, or we call it force multiplier of impact on downstream industries, including the electronics industries, automotive, medical, defense space, as well as the service space. So any design considerations that are made at the component level are going to have a huge impact at the system level. So if we look more specifically at the enterprise space, we like to think that this area is ripe for disruption. If we look at the worldwide carbon emissions of data centers, they are greater than those emitted by the entire country of Argentina and also the country of the Netherlands. If you look at these, the data centers in relation to some of the major industries, they are closely or catching up with airlines as well as shipyards and steel industries in terms of CO2 emissions. In fact, the EPA estimates that data centers account for about 1.5% of total worldwide energy production. And in the U.S., we spend more electricity powering our data centers than we do all of our televisions combined. Let's take a look at some of the factors that are driving this. And one of these is the impact of social networking. And if we take Facebook as an example, Facebook is the number 3 internet site in the world behind Google and Yahoo. Has more than 300 million active users, 120 million of which log in every single day. So this is really a testament to the stickiness of the website in terms of how many people use it. There are approximately 2 billion photos uploaded per month, more than 14 million videos uploaded per month, and the number of photos and videos that are downloaded quantities are much greater than this, in fact much more than 10x. 65 million users access Facebook via mobile phone, and there are more than 180 operators in more than 60 countries deploying Facebook products. So the net is we expect that Facebook will have a profound impact on connected devices, usage patterns, as well as the overall IT infrastructure, including products like SSD and DDR3. We do not expect any slowdown in the phenomenal growth of social networking. Again, you can see here a quote from a recent publication. Facebook is now making money, more than 300 million users, generating cash to cover its operating expenses, as well as the capital spending needed to maintain its fast-growing services. And this is all going to be driving IT spending as well as data center build-outs. So from a green storage and a memory perspective, these offer what we call disruptive value. On the storage side, it's all about green SSD. The performance is much faster than that of a 15K hard drive. The power is less than 25%. So the efficiency, when you put the performance and the power, can be multiples of hundreds of times faster. In this situation, you can replace multiple hard drives, multiple 15K hard drives in a server or in a data center with a single SSD. It's going to take up less real estate, use less components, and also have much lower cooling costs. On the memory side, with green DDR3, it has a much better TCO, or total cost of ownership, versus DDR2. You get as high as about a 90% efficiency per watt improvement. It's going to run about less than 0.6 watts per gigabyte and roughly 2 times faster than DDR2. The voltage scales down to 1.35 volt. Which is going to drive about a 70 to 73% power savings at the chip level. And once again, higher density means less components and lower cooling costs. So net is that green IT starts with energy efficient components. Green SSD and green DDR3 are indeed the building blocks for this. So if we look, SSD proliferation has begun. SSD growth will outpace all other NAND applications. This is some market research data from Gartner that shows the growth of SSD in the enterprise space in red, as well as the mainstream PC and entry PC spaces. And you can see here the chart, everything is moving up and to the right very quickly. On the enterprise space, you can see the numbers go from about 300 or 0.3 million in 2009 to about 10x that by 2012. 5.3 million units for roughly $2 billion in revenue by 2013. We do expect the SSD growth to outpace all other NAND applications in terms of its demand. If we look at the SSD performance comparison in an enterprise or a server application, Samsung SSD is going to outperform a 15K RPM HDD on multiple fronts. In fact, it can perform up to 80 times faster than an HDD and an IOPS performance if you look at it from a random read 100% duty cycle. If you look at a random write 100% duty cycle, it's about a 19x increase. So if we take this in conjunction with the power savings and look at this SSD performance as a function of IOPS per watt, this is where you really get disruptive gains, performance gains, versus a 15K RPM HDD. In fact, these numbers can reach as high as 600x that of a 15K RPM when you're talking about 100% random read cycles. If we look at a typical storage system TCO calculation and look at a couple of different configuration examples, in an HDD only configuration, which is the column in the middle on the upper left of the chart here, which shows 240 15K, 300 gigabyte SAS drives, and we look at a hybrid model that includes HDD as well as SSD, where we're simply adding about 8 100 gigabyte SATA SSDs into the picture, with an additional 24 7.2K 1 terabyte SATA drives for bulk storage. You're going to gain about a 74% improvement in IOPS. You're going to reduce your power consumption by about 36%. And again, your TCO is going to be reduced by about 31 to 32%, as you can see on the chart on the upper right hand of the screen. If you look at that TCO as a function of dollar per IOPS, it's actually about a 61% improvement. And if you look at the gaps between the HDD cost and the SSD cost over the years, there's a compounding effect here because you don't have to defrag the SSDs, and you're going to continue to recoup your power savings year over year. So the net here is we can now offer and achieve instantaneous break-even with SSD solutions. This is a quick example of some of the enterprise SSD offerings that are now out there. Recently, HP announced a Samsung SSD in their Proliant server line. This is a SATA-based product on their G6 platform and then select G5s. The capacity points are 60 gigabytes and 120 gigabytes. And you can see a quote here from one of the VPs of marketing at HP saying, "Energy-efficient server platforms will enable customers to slash their power usage and reduce costs." One of the other things that's happening is SSD is starting to drive benchmarking results. If you look at the HP Proliant, this is the DL380 G6. This is the world's best-selling server according to IDC, and this is the first TPC-H benchmark using SSD. So number one price performance for SQL, and the advantage over the previous generation is 3x improvement in performance and 7x improvement in price and performance together. So if we look a little bit into the client space and talk about some of the SSD green benefits for the notebook space. In 2007, there were roughly 160 million computer products disposed of, and about 80 to 85% of those ended up in landfills around the world, with really only about 20% being recycled. If we look at the challenge that's posed here, it's really a lithium battery recycling challenge is one of the key attributes here. And recovering these lithium-ion batteries is not economically viable. The reason for that is the scrap value is only about $100 per ton, which means 2,000 pounds of lithium-ion batteries is only going to yield about $100 in recycling. So one of the solutions that we're talking about now at a very high level is an SSD solution to battery waste. Because SSD is going to use less than 80% or 80% less power than a hard drive in a notebook, now a notebook OEM can actually choose to go with a smaller battery. So instead of having a 6-cell battery, for example, they could potentially use a 4-cell battery, knowing that the SSD power savings would offset that. So what that means is if we took all these notebooks and went from a 6-cell to a 4-cell battery, we would roughly save about 334 million battery cells over a 5-year period. So again, this is another example of how SSD can have a very strong green impact in the client space.